So the question says, prove that log base n of m is equal to log base 10 of m over log base 10 of n. So go ahead, pause the video and attempt. No, I know. You should be laughing at this question. You just eagerly want to get to the second part, right? But we still have to do it for formality. So the first part of the question here, to do this proof, right? Anytime we're doing a proof, we cannot use the law to do the proof, meaning we cannot use change of base law and say, oh, yes, it is true. We need to use definition to do the proof. So we need to use the definition of logarithm. Let's go back to the definition of logarithm. The definition of a logarithm would state, for example, let a be equal to log base 10 of m. By definition of logarithm, that is then saying that the base of 10 raised to the power of a is equal to m. And if we were to call maybe b log base 10 of n, then by the definition of logarithm, that is saying 10 to the b is equal to n. No problem, that's definition of logarithm. All right, so just remember, if you had something like log base 10 of 100, that would be equal to 2. And the reason is because 10 squared is equal to 100. All right, that's just applying definition. So now let's go ahead and apply the definition to do the proof now. So now to do the proof, we have to start with our left-hand side. Our left-hand side is equivalent to log base n of m. And remember, m in this case, we're saying it is 10 to the power of a. So this is giving us log base n of 10 to the a. By using the power rule, we can bring down the power of a, right? We can bring down the power of a. So this is equivalent to a times log base n of 10. Cool. Now, if we're to remember correctly, log base n of 10, that can be rewritten as 1 over log base 10 of n. That's true. Yeah, we can rewrite this as 1 over log base 10 of n. If you don't believe me, I'm going to bring up my calculator to verify it with some numbers. So, calculator, let's say you were asked to evaluate log base 5 of 2. Log base 5 of 25, my apologies. That's going to give you 2. Now, this would be the same as if you were to evaluate the fraction of 1 over log base 25 of 5. This is also going to be 2. All right? So you must remember that law right there. So we can rewrite log base n of 10 as 1 over log base 10 of n. So now once we get to that point, just to continue with what we have here. So now finally, log base n of m is equal to, we have a over log base 10 of n. Now remember, what was a again? A, remember, a was 10 to the power of a. All right, a was, oh, my apologies. A was this right here, log base 10 of m. So we can put that back in the numerator now. Log base 10 of m. I don't write that 10 so pretty, so let me try and fix it up. All right, now that we'll fix it up, and then divided by log to base 10 of n. Log base 10 of n. Wasn't that they wanted us to prove? There you have the proof. So we did it. All right. So write prove then. All right. You do a question like this, I want you to write soft with a capital T. Soft. That was nice. All right. Now the second part. So that was the warm-up 4 marks. but it was really preparing us for the second part. This is the real deal. Hence, given that y is log to base 2 of 3 times log to base 3 of 4 times log to base 4 of 5, all the way up to log to base 31 of 32, find the value of y. So y is equal to log to base 2 of 3 multiplied by log to base 3 of 4 times log to base 4 of 5 times all the way up to log to base 31 of 32. Now, using the change of base law, this is going to become equal to, because remember the question had said hence. That's the critical word, hence. So applying hence, this can become log to base 10 of 3 over log to base 10 of 2 times, this becomes log to base 10 of 4 over log to base 10 of 3 times, this becomes log to base 10 of 5 over log to base 10 of 4. And we're going to keep on doing that until we reach log to base 31 of 32. When we change that to base 10, it's log to base 10 of 32 divided by log to base 10 of 31. Now, as we can see, log base 10 of 3 cancels log base 10 of 3. Log base 10 of 4 cancels log base 10 of 4. Log base 10 of 5 would cancel log base 10 of 5. And there's going to be a lot of cancellation until we get to log to base 10 of 32. That won't cancel. And the log base 10 of 2, that didn't cancel. So the final answer will just work out to be log to base 10 of 32 divided by log to base 10 of 2. And I am positive that is 5, because that's 2 to the 5th power. And so the answer works out to be 5. That's your answer. All right, so the value of y, that works out to be 5. So y works out to be equal to 5. Now, if you don't believe and you wanted to check it in your calculator, remember it's just definition of logarithm we applied. So if you got to that stage and you were like, okay, let me just see, log of 32 divided by the log of 2, that's just going to be 5. Then close the bracket. So let me close the bracket. That's just going to be 5. In the same way, if you were doing log of 64 divided by the log of 2, that would be 6, because 64 is 2 to the 6, right? Those are just some laws of logarithm, all right, and so forth. So that's how we would tackle this question. All right, now this question is taken from the June 2009 paper 2, and it says solve the log equation log base 4 of x equal to 1 plus log base 2 of 2x. You may go ahead and pause the video and attempt. So in doing this question, right, we can rechange from base 4 to base 2, right? So anytime you're doing a log question, you want everything to be in the same base. So remember, change of base law. This is change of base law we're going to write here. Remember that log of a base of a number is equal to the log of a new base of the number divided by the log of the new base of the old base. So what we're saying then is this equation can simplify to be log base 2. I'm going to change everything to base 2. So log base 2 of x over log base 2 of 4, that's equal to 1 plus log base 2 of 2x. Cool. Now, log base 2 of 4, we know that in the denominator, this is now 2. So this is going to become log base 2 of x divided by log base 2 of 4. We said that was what again? We said that was 2. So we can put 2 into the denominator here, and it's equal to 1 plus log base 2 of 2x. Now we can multiply through by 2. Multiplying through by 2 will give us a simplified log equation. So it becomes log to base 2 of x is equal to 2 plus 2 times log base 2 of 2x. By laws of logarithm, we can bring up the power. So this will become log base 2 of x is equal to 2 plus log base 2 of, now this 2x, we brought up the power. We brought up the power of 2. So it's now 2x all squared. When it is 2x all squared now, what we can do is have all the logs on one side if you want. So we can bring over that to the left-hand side to have log base 2 of x minus log base 2 of 2x all squared. That's equal to 2. Rewriting this as one logarithm, it's going to become log base 2 of, this is saying x over 2x all squared is 4x squared. That's rewriting it as one logarithm, and that's equal to 2. By the definition of logarithm, we then have base of 2 raised to the power of 2 is equal to the number x over 4x squared. X over 4x squared is just, instead of writing x over 4x squared, remember that a x in the numerator will cancel out the square in the denominator. So what we're left back with is that 4, because 2 squared is 4, is equal to 1 over 4x. And we need to make x the subject, so we can end up saying that 4x is equal to 1 over 4 by cross multiplying. I know I skipped that cross multiplication step, but we're at CAPE level, so that's fine. Then we divide both sides by 4 to get x is equal to 1/4 divided by 4, which is 1 over 16. All right, so that's our answer. All we did was divide both sides by 4. 1/4 divided by 4, it's really 1/4 multiplied by 1/4, so that's 1 over 16. So that is your answer. Solving for x, x is equal to 1 over 16. Now again, when you're doing log equations, please, when you're doing log equations, make sure that you check it in your calculator to see if it is true. Log base 4 of 1 over 16. That is giving us, on our left-hand side, we're getting -2, right? So when x is 1 over 16, over here is -2. Check to make sure the right-hand side is also -2. So 1 plus log base 2 of 2 times x, which is 2 times 1 over 16. We should also get -2. And we did, so we know that we're correct. All right. All right, now this question was taken from June 2010, and it says solve the equation for x and y, the simultaneous equation that is log of x minus 1 plus 2 log y is equal to 2 log 3, and log x plus log y is equal to log of 6. Solve the equation for x and y, the simultaneous equation. So you should be laughing at this question, really nice, but go ahead, pause the video, attempt it, and have some fun. All right, so going through this equation here, right? Doing simultaneous equation, we always want to get it out of the log form. So to get it out of the log form, right, what we're gonna have to do is use laws of logarithm. So the first equation is the log of x minus 1. We can bring up the power, bring up the 2 up here to write it as plus log y squared. And that's equal to, bring up the power of 2, that's log of 3 squared. And the log of 3 squared is 9. All I did was bring up the power of 2. Using laws of logarithm on the left, side, it's going to become the log of x minus 1 times y squared. That's equal to the log of 9. So from that, we can cancel the log on both sides to end up get our equation x minus 1 multiplied by y squared, that is equal to 9. All right, so that's our equation right there. That's our first equation that we got. Nice. Now the next equation says log x plus log y equal the log of 6. So from the left-hand side, rewriting that as one log equation, it would become the log of x times y is equal to the log of 6. So what we're then saying is xy is equal to 6. So these are our two equations, all right? And we have two unknowns to solve for. So now it's just a simultaneous equation, typical simultaneous equation. From equation 2, I'm going to make y the subject. So y is equal to, if we divide both sides by x, we're then saying that y is equal to 6 over x. So y is equal to 6 over x. We're going to sub into equation 1. Sub y equals 6 over x into equation 1. So that is going to become x minus 1 multiplied by y squared, but y is 6 over x, so that becomes 6 over x all square, and that's equal to 9. Simplifying this equation, it becomes x minus 1 multiplied by 36. This is 36 over x squared, and that's equal to 9. Now, we can go ahead now. If you want, you can multiply through by x. So I put an arrow here, and on top of the arrow, I'm going to put multiplying through by x squared. The equation is going to become 36 times x minus 1 is equal to 9x squared. All right? Now, we can go ahead now further to simplify it to be a quadratic by expanding in the 36 to get 36x minus 36 is 9x squared. We can bring everything to one side to make the left side 0. And so we're going to have 9x squared. Bring over this becomes minus 36x. Bring over the minus 36 here to become plus 36. That's our quadratic equation. We can then divide through by 9 just to make the equation pretty. Dividing through by 9, we're going to have 0 is equal to x squared minus 4x plus 4. From this, we can factorize, and we have signs are the same, and both of them be negative. So that's minus, minus, and this has to be 2 and 2. So the answer we're getting is x equal 2. My gosh, all that hard work just to get x equal 2. Once we get x equal 2, remember y was 6 over x. So then we can write y is equal to 6 over 2, which is 3. So our answer, the final answer, is just to tell him that x equal 2 and y equal 3. All right, so that is it, x equal 2. All right, now this question is taken from the June 2011 question. So by substituting y equal log base 2 of x or otherwise, solve this equation for x. So I want you to pause the video and attempt. All right, pause and attempt this question. Now, it says by substituting y as log to base 2 of x, right? So let's do what they say. But before we do what they say, let's start with the question. We see that we have the square root of log base 2 of x, and that's equal to log base 2 of the square root of x. Now, this square root of x right here, can't we break up that part as x to the half? Yes, we can. We just rewrite in square root form into indices form, right? So when we write it in this form, we can always carry down the power. And so now we have a half log base 2 of x. Now you're probably wondering why I don't trouble the square root on the left side. Well, the square root on the left side has no significance for now, because the whole purpose of doing that was so I can substitute y into the entire equation. So y is log base 2 of x. So this becomes the square root of y is equal to a half of y. Ah, now we see it. That's why we didn't need to trouble the left-hand side. So we just need to solve this equation for y now. To solve this equation for y, we can square both sides. So square both sides. Squaring both sides, what we're going to end up get is y is equal to a half square is a quarter. So that's a quarter y squared. We can then multiply through the equation by 4. Multiplying through the equation by 4, just so it looks pretty, it's going to become 4y is equal to y squared by multiplying through by 4. Once we multiply through by 4, what we're getting now is we can bring over all of the things to one side. So bring over the 4y to the right side to have y squared minus 4y. That is 0. If this is 0, we can factor out y. And so we have y minus 4 is 0, or y is 0. So y equals 0 or y equal to 4. But remember, what was y? Y was log base 2 of x. That's what we substituted. So remember, y is log base 2 of x. So log base 2 of x is 0, or log base 2 of x is 4. From this, it is saying that x is equal to 2 to the 0, or from this, it is saying that x is equal to 2 to the 4th power. So the final answers are x is equal to 1, or 2 to the 4th power is 16. So that's saying x is equal to 16. Those are our answers, x equal 1 or x equals 16. And you can go ahead and check it. Always check your answer for me, please.